All right, can you hear me? Good evening. These are the brave souls of MMS. 4:30 on Thursday. You are the survivors. And it's awesome to have you here. It's a little bit of a smaller crowd, but that's understandable. But you can feel we're excited to have you here. Did you see that transition thing? If you have a hangover from last night, that's not really, it's kind of funky. You're like, whoa. So I hope not all the slides are like that, but. So this is actually material that hasn't been presented at any conference before. Some of the material you saw earlier in the week, like an overview of SP1 and some of the more detailed sessions, have had some billing before. So we're pretty excited to be able to present this information to you because it's all new in SP1. My name's Brian. This is Hema. We're going to be presenting Embedded Device Management for Configuration Manager 2012 SP1. So what we're going to talk about today is embedded device management, embedded device support, and Hema will go into a lot of details around write filters and overlays and how Configuration Manager as a management agent deals with that. We'll talk about the support we have for write filters in SP1, the importance of maintenance windows. We'll talk about persistence and how you can configure that within the UI for your deployment, and some general other improvements in SP1. Just to kind of recap what you might have heard in the overview sessions, and then we'll have time for questions and feedback. We're hoping to get a demo in as well of write filter management in action, so we'll give that a shot as well. So I'm going to start out with some material that you've probably seen in this conference, which is talking about our strategy as a management team when we're providing products to you. So recently, the Configuration Manager team was a product group, Windows Intune was a product group, and we've merged to become the Enterprise Client Management team. So as a lead program manager, my responsibilities go across a number of our products, both for on-prem and cloud. So I'm going to talk at the very end of this about exactly where we're headed as a management organization, and talk a little bit about our strategy and what it looks like to manage your entire heterogeneous enterprise. What we set out to accomplish recently in 2012, which continues in SP1, is being able to provide end users the applications they need and the data they need on any device that they're wanting to be productive, anywhere that they go, whether they're at the headquarters or whether they're on the road. And so that's a big goal of ours. That's what we're driving toward. We recognize that we're making steps in that direction. There's still more to do. Obviously, there's always more to do, as you all know. So providing users with that ability to be productive, and then providing the administrators and most of you, the customers, who are users, but also thinking about the management infrastructure that you have to provide to make all this possible. Now, users, as far as controlling access to data and authentication, they want to have a common identity wherever they are. They don't want to have to. I know sometimes when I roam or I go to a coffee shop, I try to VPN in, and many times I have to enter my credentials several times when I'm trying to get to some SharePoint sites. And so users are expecting, hey, I'm going to sign in, and I'm just going to be able to have access to all the data that I need without having to go through a bunch of hassles. At the same time, the administrators and the companies are trying to figure out, how do I protect this information? And how do I limit access to high business impact and private data? So there's a bunch of challenges, and what we're trying to provide is a single pane of glass, a single system that can provide all of that across all platforms. So we have this thing called unified device management, and you may have heard it referred to as hybrid management, where we have Configuration Manager, which is a classic on-premise solution where you deploy servers and you manage your desktops, laptops, and now you can manage Macs and embedded devices, for example, which is what we're going to talk about today. We have this unified device management, which we're going to try to empower the users to be productive. So one of the ways we do that is we provide them the choice of device, right? We want to be heterogeneous management. We don't want to be just Windows anymore. For a long time, you heard Microsoft preach, well, Windows is best, and we'll still say that. But we recognize that there's a ton of platforms in your environment that you're dealing with almost every day. And users are familiar with certain platforms and have preferences. And so letting them choose the device while you provide management of those devices is critical. Also, users are kind of expecting, they're getting used to this app store concept. They want to be able to go out, get applications they need when they need it through a self-service portal to be able to do their jobs and be productive. And also they expect that the apps that they get will be personalized to them based on their identity. And they also are kind of expecting that you're not going to trash the user experience with a lot of login scripts and all kinds of stuff like that. They're getting like, hey, I really want this to boot fast and be seamless and all of that. And you're struggling on the other side saying, well, I need to secure, I need to protect. So we're providing infrastructure that will enable you to do that through a single management interface with integrated security, compliance, settings management, application deployment, so that you can be efficient and have kind of one solution, also one vendor to deal with in many cases across these devices, which is Microsoft and our partners. And also that reduces your complexity of the management system that you have, so you don't have multiple disparate systems to do all of this management capabilities. So this is a build slide. Let me build it out all the way before I talk about it. So this is what we envision. This is what we actually have out today as a full set of management functionality. So the administrator console through a System Center Configuration Manager. You've got your on-premise infrastructure where you've got your Windows PCs, the x86 64-bit devices are reporting up, and you're managing those through policies, applications. We also introduced Mac OS X as a platform. And then for the mostly internet-connected devices, personal devices, many times bring your own phone, tablet, what have you devices to do work, we manage that through the service infrastructure known as Windows Intune. And there you get Windows RT, Windows Phone 8, iOS, so iPads, iPhones, and the Android platform. And so from this single console, you can do settings, app distribution, set security, patching, all of that through this one set of workflows that you're probably familiar with if you've been using Configuration Manager 2007 or Configuration Manager 2012. So that's what the landscape looks like. These are the goals that we have to provide to you and goals that we have as an engineering team. So what we're going to focus on today is something, like I said, we haven't gotten to talk much about, which is the Windows Embedded Platform. That falls under our more traditional on-premise management infrastructure. But there's a lot of really neat things that we've got coming in SP1 that have already arrived, actually. And I think that you'll be pretty excited that we've been able to integrate a lot of what used to be separate embedded management functionality directly into our product, furthering this vision of having a single management infrastructure. So with that being said, I'm going to hand it off to Hema, who's going to talk about the embedded devices specifically. This is her area of expertise. So, Hema.
Thank you, Brian. Thanks, everybody, for coming here. Like Brian announced, I am Hema. I'm a program manager on the Config Manager team. So I will be focusing more on mostly on the embedded devices and embedded device management and the challenges involved in managing embedded devices. If you look at, before I get into that topic, I would like to just give you a quick overview of what an embedded device actually is. So when we build an embedded operating system, it's basically choosing componentizing the big windows, which we call desktop operating system. And this enables OEMs to build small footprint images or single-purpose devices, so build images for single-purpose devices. And with that comes several challenges because not all the components are present in the image. Also, the images are heterogeneous, right? They are not a standard uniform set of images. They're different. So let's look at embedded devices, how they have grown in the market. If you look at the number of embedded devices that are floating around the market, anywhere from the stopwatch to a digital picture frame to an ATM machine to a digital signage that you see on the elevators of Mandalay Bay, they're all embedded devices, right? And actually, in fact, last night I was looking at it, and one of the digital signs is actually built off of Windows Embedded, XP Embedded, unfortunately, but it's an embedded platform. And tens of billions of such devices are in the market today when compared to phones or PCs or tablets, which are in billions and hundreds of millions of devices. So the point being, with these many devices, management becomes very critical. Management of these devices are essential to running an enterprise or running a company that has embedded devices. So let's look at how these embedded devices are being managed today, currently. There are two key segments that manage those devices today. There are enterprises that install devices such as thin clients or a multifunction printer, for example. Sorry, went back. And servers or point-of-sale systems. These are essentially managed by the admins or the IT admin department in an enterprise. Whereas there's the other segment called the device manufacturer or the service providers. One example of that is a medical device, such as the MRI scanner, right? MRI device. When the OEM, such as Siemens, builds the MRI device, images it, and delivers that device to a hospital, they sign a contract with the hospital, and most of the times, they sign a contract and say that we are going to be managing and maintaining your device. You own the device, but we own the management story for that device. So that is that segment right there. And then, so the MRI devices and some other devices like that too. There's other set of devices such as ATM devices, security camera surveillance devices, or even kiosks that are kind of the borderline. They might be, in some cases, they are managed by IT enterprise. At some other times, it's managed by the device manufacturer. So it's a gray area there. So I mentioned there are challenges with managing embedded devices. Let's go through them one by one. I mentioned that these are componentized OS, so which essentially means these are not like standard desktop operating systems. There is a subset of components that sit on any device. That poses a challenge because we do not have one management update package that can be deployed to all of these devices. Each device is very different. We used to have the second point about identifying embedded devices in Config Manager was a challenge until SP1. We were unable to correctly identify an embedded device in a collection. So we have resolved that issue. That's no longer an issue with SP1. Let's look at the third point. It's write filters. So embedded devices, such as ATM devices, typically are locked down. You do not want a user walking up to the ATM machine and making changes to the device or the image. So the OEMs lock down the device, or the image, I should say, with these cool features called write filters. There are different kinds of write filters, but because it's locked down, any updates or any deployments that are to be deployed to the device will not persist because the write filters prevent any writes onto the device. So any changes you make is transient. It doesn't stick. It doesn't persist. So when it reboots, it's gone. That poses a challenge for managing those devices. And the fourth point is very similar to the first one. The devices are very different. I have seen talking margarita mixers, stopwatches, ATM machines. So they're very different. You cannot come up with one management solution for all those different kinds of devices. And the previous slide that I showed you OEMs that actually go in and walk into the facility and update the devices. That also poses a challenge because what's the channel they use to download an update and deploy to the device? That is a big question mark. Let's look at what's supported in SP1 today. So Config Manager, prior to Config Manager 2012 SP1, there used to be another tool called, some of you must be familiar with that. It's called Windows Embedded Device Manager, WEDM for short. It used to be an add-on to 2007, the last version was. What we have done is to add on to what Brian mentioned earlier, to provide a single pane of glass, one management story from Microsoft. We have extended capabilities of Config Manager to support to light up scenarios to manage embedded devices, such as thin clients, point of sales, digital signage, kiosks, and thin PCs. So essentially, you can manage not only desktop operating systems and mobile devices, but also embedded devices. And that too, without any additional software to be added on. It's all natively integrated and seamlessly manageable. So this slide is showing you all the various operating systems that can potentially go on to each of these device categories. So thin clients can be built using XP Embedded, Windows Embedded Standard 09, or WES 7. And we support our SACM SP1, 2012 SP1, supports management of thin clients on these 3 platforms. And similarly for POS, we support the 5 different flavors of embedded operating systems. And for digital signage too, and Thin PC, only the latest version, which is the Thin PC based on Windows 7. What are the capabilities? What are the big high-level scenarios that are lit up for embedded? Operating system deployment, which uses Windows ADK. Software update management. You will notice that it's very similar to how desktop operating system or PCs are managed today. Software update management using OS servicing. Application management supports Win32 and Windows 8 applications management. Settings and configuration management using baselines, just like the regular desktop operating system. And monitoring and there's monitoring and reporting for embedded devices as well for health and compliance monitoring. And there's support for endpoint protection too. So you'll see that it's basically seamless. For an admin, all you need to know is what device are you managing. You don't need to know what kind of device you're managing. If it's in an enterprise and if you have SACM infrastructure, you're able to manage it like any other device. Okay, so how did we make this possible? Despite the fact that we have this cool feature called write filters. So there's a write filter orchestrator built into the platform, into SP1, which disables. I'll show you in more detail, and Brian has a demo too later. But it essentially, when write filters enable, no write can be made to the device. So what it does is disables write filter, and then makes the changes, and then re-enables write filter. During which time, though, a general user will be kicked out of the device, because when the write filter is disabled, the device is vulnerable, so user can potentially make any changes that will persist. You don't want that to happen, so only admins can log in at that time. And we have this concept called maintenance windows. We will get into more details about that. There's also a concept of persistence. There are 2 types of persistence, opportunistic and forced. There are certain types of deployments that you can persist forcibly. What I mean by that is even without disabling write filter, or actually, I should say the other way, even if the maintenance window is not kicked in, if you want a deployment to persist right away, you want to commit, I don't care about anything else, this is a security update, I want it to, sorry, the light is shining on my face or my eyes. Because if it's a security update, you want to apply immediately. You don't want to wait for a certain period of time. So you would actually select that option and say, I want this update or deployment to be deployed right away, applied immediately. And that's what forced persistence is. And with opportunistic persistence, with write filters, every change in state of write filters requires reboot. That essentially means you turn off the write filter, reboot the device, apply the changes, turn the write filter back on, reboot again. That's like 2 reboots in a series, right? And you don't want to do this whole reboot dance for every single update that comes along, or deployment that comes along. So what opportunistic persistence does is you queue them up such that only when you have a mandatory sort of deployment that comes along, you apply everything at one shot. So you only have 2 reboots for a set of deployments. That's opportunistic persistence. And we have support for SCEP client installation. Again, with the write filter, it gets tricky. Even if you install SCEP client, it's not going to persist. So you want that orchestration to happen there. That's supported. And of course, the signature updates are also persisted. And again, the same point, no additional software required. It's all integrated. So I talked about right filters. Let's get a little bit more into what right filters are and why it's a problem. This wheel on the right-hand side just shows you that System Center is able to manage not only the server, PC, and mobile devices, but also all the other embedded devices. It's just to depict that picture. So right filters, a deployment comes down, and like I said, it writes to the overlay because it cannot write into the disk. The right filter is enabled. But when it reboots, this overlay is thrown away. And what happens? Anything that's been deployed is lost. That is, and so how do you work around that? I mentioned earlier that you turn off the right filter, then apply the updates, and then reboot, and then re-enable. That's the only way to make it stick. And so handing over to Brian for a demo of how this all works, this magic happens.
Yes, we're going to walk through the scenarios that Hema was describing. It does require, once again, multiple reboots. We're going to put the device in servicing mode, so we may be popping back and forth a little bit here for the demo, just to save everyone the time of watching this device reboot. But so I have a fairly complex, I don't know if it's complex, but it's a little bit difficult to set up network with this device plugged into the external adapter of this behemoth laptop, which is running a one-box deployment of a configuration manager. So I was having some trouble with the DNS server. Hopefully I got that fixed. If not, we'll do a little troubleshooting and make it work. I'm pretty confident. And what the heck, I'll show you how to make it work, and you'll see me troubleshoot. But I think it'll work just fine. So first thing I'm going to do is I'm on this embedded device. This is running embedded device 7. And the first thing I want to do is show you, nothing up our sleeves kind of stuff, which is I'll run the command prompt. Now, normally this could be any type of device, some kiosk, some lockdown retail device, what have you, with any kind of application. We're back in the kind of the core of the operating system. So one thing you can do is we're going to be talking about file-based right filters. So if I go FB right filter manager, I can get a status of the right filters. And here you can see that right filters are enabled. So anything that I actually create or write, or any attempt I make to save anything, is going to be blocked. One thing I will do is, to demonstrate that, I'll create a text file. And this is a really cool keyboard to work with here. File-based right filters enabled. So for this session, certainly that will remain, but it will not persist. So the next thing I want to do is come on over here to the Configuration Manager console. And we're going to deploy an application to this embedded device. So if I go to my devices, and I can go to my demo embedded collection, you'll see I have this demo PC, which is right here, this embedded device. I'm going to go to the software library, and I will create an application. Make sure it's not there. Correct. And you've probably either done this in a lab or seen this done many times before this week, but this is using the application model, which can take a MSI, install, and create a deployment type attached to this application, and can deploy the MSI. It'll read some properties from the MSI, so it takes just a second to advance the wizard. Here we've pulled out the product code, the name, and some specific information that will be used to develop the model for deploying this particular app. I can add some additional information about the manufacturer and software version. Here's the command line. I have a number of options. I'll just keep that as the default. And I'll create that application. So the next thing I'm going to do is now I have an application, this funky garage mouse with Without Borders app. It's kind of funny. We'll notice here we have a deployment type, which is based on the technology MSI. You can deploy any number of technologies to embedded devices, Win32 apps, for support for Windows 8 applications as well. So I'm going to go ahead then and create a deployment for this application. And I'll choose Device Collections, Demo Embedded Collection, which has one client. Click Next. Add the content to the distribution point, which is a local distribution point on this site. Get that added. Content is nowhere else. I'm going to make this a required deployment. Keep the defaults. We'll deploy as soon as possible. This is a new option for embedded devices. This determines whether persistence happens immediately or opportunistically. Hema will talk about that a little bit more in detail later in the presentation. But I'm going to go ahead and commit the changes immediately at the deadline, which will cause a restart. I can do some deployment thresholds here, enable some MOM integration. We'll not do that today. I'll go ahead and deploy that. So it should just take a few moments. Go ahead and go to my monitoring. First thing I'm interested in looking at is if the content made it to the distribution point. That'll be very important. It's still in progress. Shouldn't take very long. There it is, successfully copied. This is obviously a local distribution point on the site. It only takes a moment. The next thing I'm going to do, which is always kind of a helpful thing for demos, is I'm going to go into the logs. And I'm going to look and make sure that that policy was created. One of the things I can look at the most recent date, 455. The policy provider log has made some entries. That tells me with certainty or with confidence that a new policy has just been created. It's for that deployment to this device. So the next thing I can do, you've probably seen this before, is I'm going to kick off policy evaluation cycle. By default, policy evaluation happens usually every hour. It's pretty typical for the customers that I've talked to. But we don't want to wait that long. You've got a happy hour to get to. So we're going to do it a little bit faster. So go ahead and run that policy evaluation. And it shouldn't take too long before that comes down. Go into Software Center. Oh, here we go. Software changes are required. I can click on that. It should bring up Software Center, which will kind of show me what's happening to the device. Obviously, this is not a normal situation. You'd have all of this offline. No admin would be standing here doing this, but for demo purposes, obviously, I'm going to do that. So required software changes have been made. I need to restart the device. I had an opportunity to restart from a toast, but I didn't do that, so let me go into Software Center and see what the status is. Make sure this is running properly. Oh, I've already got it up there, I think. Or here it comes. I hope. There we go. A little slow. This is kind of a slow test device, so apologies for that. This is that Garage Without Borders. This is a bit of an issue where it says 0% complete, but it's actually pending the reboot. It's kind of a known issue with this environment. So I'm going to go ahead and restart. And when I restart, the device will come up into a maintenance mode where we actually have coded a notification on the front, which will say, hey, the machine's locked, can only be accessed by an administrator, it's being currently serviced. So that should take just a moment to do that. In the meantime, why don't we get through some more of the slides while that's coming up, and then we can pop back over when it's done rebooting.
Sounds good.
Awesome.
Thanks. All right, so that'll come up. And in the meantime, I did hint about the maintenance windows. So maintenance windows are a time frame that you can configure on a collection of devices, wherein you can instruct the system to deploy or update the system only during that window period of time, right? So why does it matter? Let's look at what happens if a deployment is sent to the device to be deployed ASAP right now, right? It deploys everything, but it reboots, and it does all the, of course, it does the disable write filter reboot, deploy the stuff, and re-enable the write filter and reboot and all that. But like I said before, it's going to do this for every update, and if you don't, and every time there's a deployment that comes as marked as ASAP, it's going to do right then and there. It's not going to wait for a time, optimal time. And this is not great if it's like an ATM machine that's at 4 o'clock. I'm going to an ATM machine, it's trying to get a deployment ASAP, it's rebooting. I'm like, whoa, what happened to my transaction, I wonder? Or a controller in the assembly line, right? In a car assembly line, it's not a good experience. So, of course, maintenance windows. I'll keep repeating this, pardon me for that, because maintenance windows are our friends for embedded devices. So what happens without a maintenance window? So a deployment notice comes along. It downloads the content, right? Because it doesn't know there's a maintenance window. It just knows, okay, I got a deployment notification. Now I have to get the content downloaded. And it disables write filter because it knows it's a write filter enabled device. Disable write filter and reboot immediately. But the content was downloaded before the write filter was disabled. So what do you think happens after reboot? The content is gone. Oops, it was downloaded to the overlay, right? So now, but the policy is still there, so it says, oh my God, what happened to the content? I'm supposed to be downloading a content. Well, no worries. I'm going to download the content again. So twice, notice there's twice the content has been downloaded. And after that time, everything goes happily because it installs the content, re-enables write filter, reboots the device, everything happens. Very good. But the only downside is that it's going to download the content twice. However, we've added the smart logic to maintenance windows, or leveraging maintenance windows, is that with a maintenance window, you do not have to do this downloading of the content twice. So what happens in this case? A deployment notice comes along. Now it knows the device has a maintenance window set on its collection, right? So it's not going to do anything. It's just going to say, okay, I'm going to wait until the maintenance window arrives. It's 4 p.m. or 4:10 is what it's configured. I'm going to wait. And now the 4:10, it's 4:10 now, maintenance window arrives. At this point, I'm still not going to download the content because I know it's a write filter enabled device. I will show you how it knows it. That's another improvement we have made, but it knows it's a write filter enabled device. So it knows it should not download the content because otherwise, what's the point, right? So it reverses the whole sequence. It first disables write filter. Of course, requires reboot. And when it reboots, it then downloads the content because now it knows, okay, write filter is disabled. I'm safe to download content because now it's going to persist. And then it installs the content and everything goes happily. So now you see why a maintenance window is definitely required. I also mentioned earlier that we have endpoint protection support. So SCEP installs will persist. It has the same orchestration of write filter built in the system, so the SCEP installs will persist. And signature updates, if you're aware, it's at least 3 times every day. It happens frequently, and you don't want so many reboots each day. So that's also taken care of. It does the same write filter magic and updates the signature files. And one other thing is for client installation, imagine the SCEP client, when it installs the write filters enabled, it's not going to persist. Same issue, right? So we added a new setting to handle that. So commit endpoint protection client installation on embedded devices with write filters. The default value is set to yes. This essentially tells the system that I don't care about maintenance windows or anything. I want this client installation to persist right away. It's almost like ASAP, but with right filter orchestration. So that takes care of that. Should reboot ready?
Sure, yeah.
I will continue with the content after Brian's magic demo.
I don't know how magical it is, but... so let me switch over, and you'll see this machine is now in servicing mode. The right filter has been disabled. I will go in and demonstrate that. There has been a delay in logging in, so hopefully it'll log in fairly quickly. Wait for it. There. Phew, good. And first thing you'll see, notice that, as Hema pointed out, the content did not download. It downloaded once we were in servicing mode. That file that I created is gone because right filters were enabled at the time I created that file. But the config manager agent has come in and orchestrated, as Hema pointed out, the right filter disable. You can see the application mouse without borders, a little funky application icon. So that application was installed and persisted. If I go to my command prompt, I can show file-based right filter manager. And you'll see that currently the filter state is disabled for this session. Now, since I am in servicing mode, I can go ahead and create a file again. File-based right filter disabled. So anything I do while the right filters are disabled will persist. I could install some apps, write some scripts, run some particular tasks that I would need to run on this device, and they would all, whatever changes were made, would persist. So at the next reboot, restart, right filters should be re-enabled, and the device should be out of servicing mode. So it would have, yes, but
yeah, since we logged in as administrator while it was being serviced, it let us in because it's an administrator, so you can make the changes. But for general user, though, it wouldn't let the person in till the servicing is complete.
correct. Good question. It will do the install and then reboot. Here we kind of disrupted that so that I could show you what if someone attempted to get into it, what it would look like while it was in servicing mode. So we did tweak the device a bit. I think that answers both those questions.
Right.
Yeah. Any other questions? I'm sorry. What was the question? Sure. Any difference when it's not on the file base but the enhanced? I believe the orchestration is the same. Hema would be able to speak to that.
Orchestration is exactly the same. However, the exclusion, you can have exclusion for file-based right filter, whereas not for enhanced right filter.
And one more question over here.
The servicing mode UI, unfortunately, that is not customizable at all, that particular UI. It's,
okay.
Yeah.
Good questions. Thank you. We'll also get some questions at the end as well.
Yeah, but feel free to jump in and ask questions, of course. Yeah. Great. Thanks, Brian.
Yep.
So we also talked a little bit about persistence, and Brian showed you. The text here is from an old screenshot. Apologize for that, but what Brian showed you earlier is actually the latest text on the checkbox. So I'm talking about the last checkbox on the screen on the right-hand side pane. This is the one that says, upon deployment deadline or in maintenance window, disable right filter and force reboot. Right? This is the forced persistence. Basically what that means is I want to commit this change ASAP, so do the right filter thing right now at the deadline or better maintenance window. But if it's ASAP, it might just do it. And then commit the changes. So it's forced persistence, right? So, so this is without the persistence option. What happens is put it in the overlay and wait for another deployment to come along that has the persistence flag set. So there are ways to use this smartly so that you can bundle a forced persistence deployment and opportunistic persistence deployment together, time it such that they will all work together and within the maintenance window. We have some guidance around that. So what can be forcefully persisted? These deployment types such as applications, packages and programs, software updates, and task sequences. These are the only 4 that have the checkbox option enabled. Whereas for client agent settings, it's not available. However, that's not a big issue because every time the device reboots, machine policies are evaluated first, which means the client agent settings are going to be brought down again anyway. So that's not a big issue. Settings management and power management also do not have that option to persist or force to persist. For example, if settings management, you can still work around that. Like I said earlier, you can time it. You can send another deployment, such as a package and program, an empty one. All you would do is create an empty package and program and check that box to persist right away. And what you would do is you would deploy the settings management policy first and then time the package and program right away. And that way, since the packages and programs have the persistence flag set, both of them would get persisted at the maintenance window. So you can work around the opportunistic persistence. The local settings, like which? I don't think we handle GPO settings, do we?
The question is, what about the domain-based policy settings? I don't know actually how group policy handles orchestration of the policies to the right. Now, I know that our DCM policies would apply just as Hema described, but I'm not sure how group policy does it. But I could find out if you come up afterward. I can get your information.
Yeah.
Yeah.
Thank you. All right. So there's another issue with persistence, right? So I want to talk about the state and inventory data. What happens with inventory data is that first time the inventory is collected, it needs to send it to, first inventory data is sent to server, but it needs to maintain a copy so that it can understand what it has already sent. So it doesn't send the first inventory data every time. It only sends a delta, right? Ideally, it would have a delta, send it to server. However, since it's not persisted, because the write filter is enabled, what happens is it keeps sending first inventory data over and over to the server. That causes confusion. Server thinks, wow, I just got this inventory data from the same device multiple times. What's going on, right? It's confused totally. And what it does is it sends a resync to client. And this will happen multiple times for multiple devices, and that would add load to your server and to the network. So, so then, how do we get around that? File-based write filters, as this gentleman asked, is one of the write filters that we recommend that you guys use on an embedded device, exactly for this reason. With file-based write filters, you can exclude certain folders. Inventory and state message data are written into a SQL CE database, which you can exclude from write filter enablement, right? So when you exclude that folder or SQL CE database, what happens is system allows writes onto the database. So inventory data can be written into SQL CE because it's excluded. So what happens in that case is first inventory data is written, made a copy because it's excluded from being locked. And so from then on, it only sends delta information to server and everything happens fine. All right, so we talked about file-based write filters. And with file-based write filters, you can have file or folder exclusion defined for each device separately. Enhanced write filters, we only support the RAM mode, not the RAM reg mode. I know somebody asked me before the conference, before the session, if we support that. No, we do not, unfortunately. And of course, it's written onto overlay, which is discarded after reboot. The other new write filter that's added to newer versions of embedded operating system is unified write filter. These write filters are a combination of file-based write filter and enhanced write filters. Going forward, for newer versions of embedded operating systems, they are going to stop FBWF and EWF. We're only going to make UWF available on those operating systems. However, SP1, Config Manager SP1 does not natively support management of UWF devices. There are ways to get around it. You can you can define task sequences to get around it, or you can use another tool outside of Config Manager called ELM, which is an embedded lockdown manager, which is developed by the embedded platform team, and it's available for download until Config Manager will natively support it. So you can use that. And with unified write filter, you can use HORM or registry or file exclusions. Any questions on the UWFs? Okay. All right, so we have made, I've talked about various improvements that we have made to SP1 to be able to support embedded device management. I wanted to just highlight a few more improvements that we have made. Operating system deployment improvements. So earlier, before SP1, any operating system deployment OSD tasks would have to be run, or content would have to be downloaded to the local drive and run from there, which is kind of problematic for small form factor devices. You don't have local disk space. So with this new parameter for a task sequence called apply operating system, you can run it directly from the distribution point. And we've added another variable called SMS TS post action, which is the reason we added that was with a primary goal of being able to enable write filters at the end of task sequence, right? So you want everything to happen in a task sequence, and in the end, you want to enable write filters. So this is a perfect variable to configure at the end of task sequence. You can actually run this command, or run any command at the end of task sequence with this parameter set. And we've also added some discovery data record improvements. So we have now the ability to identify write filter enabled device. Now, because of that discovery improvement that we've made, you can now create collections of embedded devices based on that DDR value. So you can now actually build an embedded collection and say, write filter capable device, if it's equal to true, then do this. In fact, for UWF management, you could use the same criteria and script it such that, if it's a write filter enabled capable device, do this. So you can still work around UWF. And we also have made some client-side improvements, as Brian showed in his demo. When the computer enters servicing mode, the general user is kicked out, and only admins can log on to the computer while it's being serviced. And so when Brian walked through the demo, he showed that when he deployed the application, it had to be required and not available, because if it's available, the software center has disabled the option of install for an embedded device. So even if you make it available, you deploy it, it's useless because you cannot really install it from there. So software center blocks installation of write filter enabled devices. User cannot change their business hours, non-business hours, and they cannot postpone deployments to non-business hours for embedded devices. And there are some write filter considerations. Settings management, DCM, is not write filter aware. So if there's no write filter orchestration for settings management, DCM in SCCM or CM12 SP1. You have to do a manual write filter by scripting it, or however you want to do it, like WMI query or something like that. And we talked about opportunistic persistence during maintenance window. That's the only option available. And with Windows 8 applications registered during user logon, that's how it's typically done. This is a problem with write filters because if you're installing few applications, fine, you can go and read register. But if you have multiple applications, many applications on the device, that's not a great experience. So you would have to have an admin log on to finalize the app registration for Windows 8. And with that, I'll hand over to
Yep, so we're going to wrap up here, and I'll just show one thing back on our embedded device. So this restarted, and then this is start screen for this mouse application. Certainly, any kind of application that had been developed for this embedded device would have launched, and you'd be back up and running with your specialized tasks. Notice that this text file here stayed while it was added during the maintenance mode. And if I were to go here and go back into looking at our, it's a funky thing to me, it's a really tiny file. Take a look at the status again. Uh-oh.
It takes a little longer to.
Why was it still the same?
Yeah, it's still because you logged in as administrator.
Oh, because I logged in as
The
administrator,
orchestration
disrupted
is
it?
not complete yet.
Okay, sorry. So it's still disabled because I interrupted the orchestration. But anyway, I hope you get the idea. So let me switch back. Get you out of here. So some best practices for using embedded devices and doing management with the Configuration Manager. Hema talked a lot about using maintenance windows to do your servicing of these devices, and make sure that your max runtime you set is enough so that all of the actions that you've taken that you want to take place, like task sequences, any kind of apps or package programs, anything you want to deploy, will be deployable. Also plan for persistence. Decide what things you think would come at the end that would be the final committed persistence versus opportunistic. That will minimize your reboots required. Make your deployments required, because as Hema mentioned, available install will not happen when when the right filters are enabled. Also, it helps the agent operate better when you add these exceptions to the persist state for inventory data, and they're listed there for your reference. And because we don't yet support unified right filters, we are working on that, but we don't yet. There is a WMI provider that you could read through a script or a task sequence variable or something along those lines to go ahead and do enable or disable of the unified right filter. So with that said, these are probably already all done, but I wanted to thank you all for coming to the conference, for all the work that you've done with us, helping us design, make the right products for you, all the discussions we've had. We really love having your feedback. We love having you come to the conference. So appreciate it. Have a safe travels home, and enjoy Vegas for the few more moments that you have. So thank you so much.
Thank you, guys.